Okay, now we have to look at these three equations. This is the first one. I run it as a multivariate regression or multiple linear regression. Y as a function of x1 and x2. Then you have the parameters b1 hat and b2 hat. And then U stands for residuals, U hat. And then in the second regression, I deliberately exclude x2. Then I suspect I commit underfitting. So y is a function of x1 only. And then for the constant, I don't want to use hat again. So is it called wave or something? B0 wave is the constant. B1 wave is the slope parameter. And then the residuals, I don't want to use U anymore. So I call it W hat. And then I run a third regression. X2, the omitted explanatory variable, is a function of x1. Okay, and this term, I don't know how to say this in English. Is it called lambda or theta? I'm not sure. Okay. This slope parameter shows the relationship between x1 and x2. Okay. And then now I want to substitute x3 into x1. Do you see this is my x2? And this is my x2 again, running the third regression. Then I do the substitution. Then you rearrange the terms until you get this. Let me stop for 1 minute for you to go through that. And actually, you have to do all the calculations on a piece of paper, actually. So let me stop for 1 minute for you to go through everything. Okay. So now I want to compare this one, the slope parameter in connection with x1 in the second regression that I suspect I commit underfitting. So b1 wave is actually equal to, now you see this, okay, you see x1 there. So b1 wave is actually equal to your b1 hat from the original regression plus this one, the slope parameter in connection with x2, okay, which you omit in the second regression times this term I can't pronounce. I don't know if it is called lambda 1 or theta 1, okay? Then it is about the direction of the bias. It means by omitting x2, what is the direction of the bias on the slope parameter of the explanatory variable, which you still keep, x1, okay? This one, okay? And then the focus is on the product of these two, actually. Is it positive or negative sign? Okay, focusing on this slope parameter, these two would be exactly the same only if B2 hat is exactly 0. Because if your B2 hat is 0, then this thing falls away, isn't it? Then my B1 wave would be exactly the same as B1 hat. But B2 hat is only 0 if x2 is an irrelevant explanatory variable. It means I rather commit overfitting in the first regression. Okay, and then the second possibility for these two to be the same is this is 0. In other words, there is virtually no relationship between x1 and x2 at all. They are totally uncorrelated. So keep these explanation in mind and these calculations as well. I'm going to ask you to do the calculations actually. And then this table is a bit confusing. Okay, I rather want to do a few question in class exercise question 4. Okay, I want to know the direction of the bias on this slope parameter as a result of committing underfitting, excluding x2. Okay. Okay, and then this is the formula actually. So let's do all 3 sub questions from question 4. Question 4.1, expenditure. The multiple linear regression is expenditure is a function of price and income, and I think B2 hat should be positive because the higher the income, the higher the expenditure, assuming we're dealing with a normal good. B1 hat should be negative because the higher the price, then it becomes expensive, then the lower the expenditure. Then in the second regression, I take out income, then I suspect I commit underfitting. So now I want to know by removing x2 income, what is the impact on this slope parameter in connection with price, x1, which I still retain in the regression, the impact on B1 wave, the slope parameter. And this is the direction of the bias, which is equal to, again, just to remind you, the product of these two terms, okay? B2 hat, which is this one, the slope parameter of the explanatory variable you omitted in the second regression. We already know it is a positive sign. And then what is this? Is it theta 1 or lambda 1? I don't know how to say this in English. The direction of the relationship between x1 and x2. And the direction should be positive, okay? It means income is higher, then the price will be higher. The reason is you have to go back to your first year economics, supply, demand. If your income increases and the good is a normal good, wouldn't the demand for the product increase? Then there is a rightward shift of the demand curve, and then at the new equilibrium after the rightward shift of the demand curve as a result of increase of income, then your new equilibrium price will be higher. So it is positive relationship. And then positive times positive, giving you a positive answer. Then it means upward bias. It means by excluding income, then there will be an upward bias on this slope parameter. Then an example would be maybe in the first regression, the slope parameter B1 hat would be 4. And then in the second regression, by excluding income, there is an upward bias. Then it goes up a bit, but it is still negative. Okay, then it could go up to -3, then upward bias. Okay, happy with the first one. Then the second one, quantity demand of MP3 is a function of price of CD. Positive relationship, because if price of the CD becomes more expensive, you would rather demand the substitute, MP3. Okay, so positive relationship. And then price of MP3 versus quantity of MP3, you know the negative relationship, the law of demand. So B2 hat is negative. And then in the second regression, I suspect I commit underfitting. I take out the price of MP3 X2. Now I want to know by excluding X2, what is the impact on this slope parameter B1 wave. Again, the product of these two terms gives you the direction of the bias. First of all, B2 hat, you already know it is negative. And then this shows the relationship between price of MP3 and price of CD. It is a positive relationship. The reason is if price of MP3 becomes more expensive, then people would increase the demand of the substitute product, which is CD. Therefore, the demand curve for the CD will shift rightwards. And then at the new equilibrium, price of the CD, it is just a matter of time before CD also becomes more expensive, thanks to MP3 becoming more expensive. So eventually price of MP3 and price of CD would go up at this. Okay, so positive relationship. Then negative times positive, meaning downward bias on this. So an example would be in the first regression, maybe this is the slope parameter 4.5. In the second regression, by excluding X2 price of MP3, it causes downward bias on this slope parameter. So it could drop to 2.5, but it is still positive, but downward bias. Okay. Last one, the yawning frequency is explained by sleep hours. So if you sleep less, you are going to yawn more. So obviously negative slope parameter. And then the number of tests, actually, if you have more tests, you are under stress, then you are going to yawn more in the daytime. So positive. Okay. And then the direction of the bias, actually. Again, the same product of the two terms, and then positive here, and then this one. The relationship between the number of tests and sleep hours should be negative, because the more tests you have, you will burn the midnight oil, you study longer hours, then you would suffer with shorter sleep hours. So negative relationship between x1 and x2, positive times negative, then downward bias. So a mathematical example would be maybe in the first regression, this is the slope parameter 5. Then by excluding x2 test, the test variable, there is a downward bias on this slope parameter. So it could decrease to -7.5 downward bias. Okay. Okay, and then this I want to explain in the last video. I want to skip to this summary table actually. Okay. I hope it is going to be helpful to you. The 3 properties of OLS statistics is more or less the same for simple linear regression and multiple linear regression. Assumptions. of the regression model, 5 assumptions for the first one, SLR, and then for MLR, 6 assumptions. You see some changes in the third assumption. And then the sixth assumption is the new assumption about the error terms normally distributed with mean of 0, variance of this. This is the sixth or the new assumption in MRL. This I'm going to explain in the next video or the last video of this chapter about the factors causing the influencing the variance of the regression parameter. In the simple linear regression model, you already learned that if sample size increase or this variation of x increases, it means the total sum of square of x increases, then it is good news. They are both good news, causing the variance of the parameter to go down. Remember, we want the variance of the parameter to be smaller variance. And then the last one is bad news. If the variance of error term increases, then sorry, the variance of the parameter would also increase. So in other words, we want this to be smaller so that the variance of the parameter would also be smaller. And then in the next video, I would also talk about the similar explanation applies actually. Okay, I think first two, the third one is not the same. R square of auxiliary regression, which is something new, but you actually learn it from your undergraduate year. Auxiliary regression, I don't know if you remember VIF, variance inflation factor. So auxiliary regression is about regressing one x on the other axis, okay, from the multivariate regression model. But more on this part in the next video.